Welcome back to Talk Tensors, the podcast that takes you deep into the world of machine learning research.
That's right.
And today, we're going to do a deep dive into a paper that has people talking. It's called VideoLLaMA 3, Frontier Multimodal Foundation Models for Image and Video Understanding.
Yeah, it's a mouthful, but it's definitely one that's caught my eye too.
So much to unpack.
It really is.
And, this whole idea of multimodal AI, it's not just hype. It's really gaining momentum.
Absolutely. It feels like we're at a turning point. For so long, AI was all about text or all about images.
Right, like separate silos.
Exactly. But now we're seeing this push to integrate those different modalities to build models that can understand and reason about the world in a more holistic way.
It's like AI is finally getting a sense of, common sense.
Yeah.
The kind of understanding that we humans take for granted.
Yeah, like being able to see a picture of a dog and also understand the word dog and how those two things are connected. And then on top of that, being able to understand a video of a dog running and barking and how that all fits together.
Right, it's like moving from recognizing patterns to actually comprehending meaning.
That's it.
And that's what's so exciting about this paper, about VideoLLaMA 3. It's not just about tacking on video understanding as an afterthought. It's about building a strong foundation in image understanding first.
Exactly. The researchers really took this interesting vision-centric approach.
So they're essentially saying, hey, videos are just sequences of images. If we can nail the image part, we're halfway there.
And there's a real practical advantage to that approach, too. High-quality image-text datasets are much easier to come by than video-text ones.
So it's like working smarter, not harder. They're leveraging the abundance of image data to build that foundation.
It is.
Now, let's get into the nitty-gritty of how they actually trained this AI to become a visual whiz. They start with a stage called vision encoder adaptation. Can you unpack that for us a little bit?
Sure. Imagine you're teaching someone to appreciate art for the first time. You wouldn't just show them tiny little, cropped images, right? You want them to see the full picture with all the detail and context.
Right, you'd want to give them the full visual experience.
Exactly. And that's essentially what this stage does for the AI. It trains the AI to handle images of any resolution.
So no more squeezing those widescreen images into tiny boxes.
Exactly. It's like giving the AI a set of, high-powered glasses that can zoom in and out as needed.
I love that analogy. So it gets the full picture, literally.
Precisely.
Now, once the AI has gone through this vision encoder adaptation, what's the next step in its visual bootcamp?
Stage 2 is where things get really exciting. It's called vision language pre-training, and it's all about connecting those eyes, so to speak, to a brain by feeding the AI massive amounts of image text data.
So it's like teaching a child to name the objects they see, but on a massive scale.
Yeah, exactly. And the images they used weren't just random snapshots. They were very deliberate about including a wide variety of images.
Okay, so not just your cat pictures then.
No, we're talking photos of scenes, objects, documents, charts, even images with embedded text like street signs. It's like they created a visual encyclopedia for the AI.
A really comprehensive visual education.
Exactly.
So at this point, the AI has a solid foundation in image understanding. But we're ultimately aiming for video comprehension, right? How does the training progress from those still images to those moving pictures?
Well, that's the focus of the third stage, multitask fine-tuning. And this is where they start bridging that gap. They challenge the AI with different tasks, like answering questions about images and even captioning videos, which may seem surprising at this stage.
Wait, video captioning already? I thought we were still in the image phase.
Right, you'd think so, but here's the interesting thing. They found that giving the AI these video-related tasks actually improved its image understanding, too.
So it's like cross-training for your brain. You might be focusing on weightlifting to build muscle, but adding some cardio can surprisingly boost your overall strength.
It is. It's like those different visual challenges reinforce each other, leading to these synergistic improvements.
Fascinating. So the AI is becoming a visual multitasker.
Exactly.
Okay, so the AI is getting pretty good at understanding images and starting to dip its toes into the video world. But when do we finally get to the truly video-centric part of the training?
Well, that's the focus of the fourth and final stage, which is aptly named video-centric fine-tuning. And now remember, they've already laid this solid groundwork with image understanding, so the AI is primed to learn from videos. And they didn't just throw any videos at it, they incorporated streaming video data, similar to how platforms like YouTube work.
Ah, so they're training it on dynamic content, stuff that's happening in real time.
Exactly. It's like teaching the AI to follow along with the story as it unfolds in real time.
I see. But videos can be massive files, right?
Yeah.
How do they avoid getting bogged down in processing all that visual information?
That's where a couple of clever tricks come into play. First, there's dynamic resolution input. It's the same principle we discussed with images applied to videos.
So no more squeezing a widescreen epic into a tiny box.
It gets the full cinematic experience.
I like it. What's the other trick?
The other trick is called differential frame pruner, or difffp for short. Think of it as a smart video editor for the AI. Instead of analyzing every single frame, difffp helps the AI focus on the frames where things actually change.
It's learning to pay attention, just like we do when we watch a movie. Tune out the boring parts and zero in on the action.
Exactly. Makes the processing much more efficient and lets the AI grasp the essence of the video.
Pretty clever.
It is. Now, before we move on to the results of all this training, I'm curious about the data itself. You mentioned earlier that finding high-quality video data can be a challenge. How did they approach that?
They were incredibly meticulous about the whole data selection process, filtering images by aspect ratio, aesthetic score, even text-image similarity. It's like they were assembling a visual library of the highest quality for the AI.
So it's like they hired a team of museum curators to find the perfect collection of visual knowledge. Exactly, and that attention to data quality really made a difference in the end. We'll get into that more when we look at the results, but it's a crucial point.
Okay, so we've got this AI trained on a curated collection of visual data and equipped with some clever tricks for processing those images and videos. It all sounds incredibly promising, but the real question is, did it actually deliver? And that's what we'll explore in part 2 of this deep dive, so stay tuned.
Welcome back to Talk Tensors. We're picking up our deep dive into VideoLLaMA 3, this really exciting AI that's pushing the limits of image and video understanding.
Yeah, in part 1, we covered a lot of ground.
Yeah.
We're going to talk about how this model was trained, its unique approach to, understanding images first.
Right, building that strong foundation.
And those clever tricks for processing all that visual information. But now for the real test. How well does this AI actually perform? Does it live up to the hype?
Well, the researchers really didn't hold back when it came to evaluating VideoLLaMA 3. They benchmarked it against other state-of-the-art AIs on a whole range of tasks, and I gotta say, the results are pretty impressive.
Okay, give us the highlights. What were some of those standout achievements?
So in image understanding tasks, VideoLLaMA 3 really showed off its ability to understand charts and graphs, even surpassing specialized models in certain cases.
So it's not just about recognizing shapes and lines on a chart.
No.
It's actually extracting meaning from the data itself.
Exactly. It's demonstrating a deeper level of understanding. It's not just pattern recognition, it's actual interpretation of the information.
That's a big step. I mean, the AI that can actually reason about data and draw insights from visuals, it's what we've been talking about, getting closer to that human-level understanding.
It really is.
Now, what about other image-based tasks? How to do there?
It excelled in visual question answering, showing a nuanced understanding of the relationships between objects within images. Imagine a picture with a bunch of stuff going on, multiple objects, actions, and VideoLLaMA 3 can not only identify those elements, but also understand how they relate to each other in space and time.
So it's almost like the AI is building this mental model of the scene, like how we humans perceive our surroundings.
Right, exactly. And that ability is crucial for tasks that go beyond just simple object recognition.
Right. So we're seeing some pretty impressive stuff in the image domain. But of course, the big challenge is video understanding, right? I mean, that's where things get really complex. So how did VideoLLaMA 3 do when faced with moving pictures?
It really exceeded expectations there, too, achieving state-of-the-art performance on benchmark data sets that require temporal reasoning. Think about understanding the sequence of events in a video, being able to predict what might happen next.
Yeah, that's a whole other level of comprehension.
Right. And what's even more impressive is it even showed promise in understanding longer videos, which has always been a major hurdle for AI. Following a storyline over a longer period, remembering key details, connecting events across different scenes.
Like, is the AI developing a sense of narrative? Being able to follow a plot like we do when we're watching a movie?
It's really heading in that direction. And what's notable is its versatility. They tested it on all sorts of videos, from short clips to full movies, and it consistently performed well, which tells us the underlying principles are really robust and can adapt to different types of video content.
So it's not just a one-trick pony, it's got a broader range.
That's right.
It can handle a wide variety of stuff. Now, before we dig deeper into the technical side of things, what makes this AI tick, I want to go back to the data for a second. You've emphasized how important high-quality data is for training these models.
Oh, absolutely.
So how did that play out in practice with VideoLLaMA 3?
The researchers were incredibly meticulous in how they curated and prepared the data. They understood that what you put in is what you get out. They weren't just dumping random videos into the system. They carefully selected and filtered the data to make sure it was diverse, representative, and accurately annotated.
It's like they were building a balanced diet for the AI, making sure it's getting all the right nutrients to grow strong.
Exactly. And that focus on data quality really did pay off. You can see it in the results. It's one of the key factors that contributed to VideoLLaMA 3's impressive performance.
Okay, so they've got this solid foundation with this vision-centric approach, the high-quality data. But let's get into the nuts and bolts now. What are some of the key technical innovations that make VideoLLaMA 3 tick?
Well, one of the standout features is its ability to handle different resolutions for images and videos. This is all thanks to a technique they call any resolution vision tokenization, or AVT for short.
AVT, okay, sounds technical.
It is, but I'll try to break it down. Remember how traditional computer vision models often require images to be resized or cropped to fit a specific format?
Yeah, like forcing a square peg into a round hole.
That's a good way to put it. Well, AVT allows VideoLLaMA 3 to process images and video frames at their original resolution, so no information is lost.
So no more squeezing or stretching. The AI can work with the visual information as it's intended.
Exactly. It's like having a custom-tailored suit that fits perfectly.
I like that. So how does AVT actually achieve this flexibility?
It comes down to something called vision tokens, which are basically the building blocks of the AI's visual understanding. Each token represents a small patch of the image or video frame, and the AI learns to associate those tokens with different features like edges, colors, and textures.
Okay, I'm following so far.
The cool thing about AVT is that the number of tokens used to represent an image can vary depending on its resolution.
So a higher resolution image would have more tokens, capturing more detail.
Exactly. While a lower resolution image would have fewer tokens, focusing on the most important features.
Makes sense.
So the AI can adapt to the specific needs of each visual input, making sure it captures the right level of detail.
Efficiency and flexibility, that's the key.
Precisely.
Okay, so AVT takes care of the resolution problem. But what about the challenge of processing all those video frames? We talked earlier about how analyzing every single frame can be really redundant. How does VideoLLaMA 3 deal with that?
Well, they came up with a pretty clever solution for that called differential frame pruner, or difffp for short. Think of it as a smart filter for the AI, right? It identifies those key moments in a video and gets rid of the redundant frames that don't add much new information.
That's like having a really good film editor. You're cutting out all the filler and leaving just the important stuff.
Exactly. difffp analyzes the differences between consecutive frames, looks for changes that are significant enough. If there's not much change, it just skips that frame, saving processing time and resources.
So it's not wasting time on those boring parts.
Nope.
It's paying attention to where the action is.
Yeah.
Just like our brains, right? We filter out the unimportant stuff.
Right, exactly. A form of selective attention, focusing on what matters.
Okay, so difffp is a big help in making video processing more efficient. But video also brings in this whole element of time, the sequence of events.
Yeah.
How does VideoLLaMA 3 handle that temporal dimension?
That's another area where they made some clever innovations. They actually incorporate timestamps directly into the data, so the AI has precise timing information for every frame.
Oh, so it's like giving the AI a stopwatch so that it knows exactly when things happen in the video.
Exactly. And this temporal awareness is really important for tasks like understanding the flow of events, answering questions about when something happened, or even predicting what might happen next.
It's like giving the AI a sense of narrative structure. It can piece together the story as it unfolds over time.
Right. That's a great way to put it.
Now, we've talked a lot about these impressive technical innovations, but, every project has its challenges. What were some of the hurdles the researchers had to overcome while developing VideoLLaMA 3?
One of the biggest challenges, as we mentioned before, was the lack of high-quality video data, especially when you compare it to the amount of image data that's available. They needed videos that were not only diverse and representative, but also accurately annotated with timestamps, captions, and all the other stuff needed for training.
So it wasn't just a matter of grabbing a bunch of videos off the internet. There was a lot of work involved in selecting and preparing the data.
Absolutely. That data curation process was a huge undertaking. They spent a lot of time and effort ensuring the quality and consistency of the training data.
It really highlights how important the data is in AI. You can have the most sophisticated algorithms in the world, but if you feed them bad data, you're going to get bad results.
That's right. Garbage in, garbage out.
So they tackled the data challenge head on. But what about the computational demands of training such a massive model? I mean, we're talking about processing huge amounts of data, billions of parameters.
Yeah, that's another big hurdle. Training a model like VideoLLaMA 3 requires serious computing power. You need access to top-of-the-line GPUs, distributed computing clusters, and the right software to manage it all.
It's a massive undertaking, resource-wise and in terms of expertise.
It is. But as you can see from the results, it was worth it. They've really pushed the boundaries of what's possible in multimodal understanding.
Definitely. And, this is really just the beginning. We're just starting to scratch the surface of what AI can do when it comes to understanding and interacting with the visual world.
Absolutely.
Now, in the final part of our deep dive, we're going to shift gears a bit and explore the potential applications of this technology. How could VideoLLaMA 3 be used to solve real-world problems and, benefit society as a whole?
Oh, the possibilities are endless. So join us for part 3, where we'll dive into those potential applications and then wrap things up with our favorite segment, Novel Notions, where we'll brainstorm some, maybe a little crazy future research directions inspired by this work.
Welcome back to Talk Tensors. We've spent the last 2 episodes really digging into the nuts and bolts of VideoLLaMA 3, this groundbreaking AI that's really changing the game when it comes to understanding images and videos.
Yeah, we've seen how it learns, how it's trained, and how it performs on all these different tests. Really impressive stuff.
But it's not all about, technical achievements and benchmark scores. The real question is, how can this technology be used to actually solve real-world problems? How can it benefit society?
That's where things get really exciting. The potential applications of VideoLLaMA 3 are vast. Think about it. Imagine AI assistants that can not only understand your voice commands, but also see what you see, understand your surroundings.
Like a sidekick who's always got your back and can actually see what's going on.
Exactly, providing you with, really helpful and relevant information.
I can see it now, walking down the street and my AI assistant's like, hey, watch out for that pothole.
Oh.
Or, hey, there's a great coffee shop just around the corner. Want to try it?
Exactly. Or imagine shopping, right? You're looking at a product and your AI assistant can pull up comparisons, reviews, maybe even suggest something better.
It's like taking personalized assistance to a whole new level. And, it's not just about convenience either. This kind of technology could be huge for accessibility.
Absolutely. For people with disabilities, this could be game-changing. Imagine an AI that can describe visual scenes for someone who's visually impaired or provide real-time captioning for someone with hearing difficulties.
It's really powerful. AI that can help us break down barriers and create a more inclusive world.
That's what I'm excited about.
And it's not just personal assistance either. Think about the possibilities in fields like education.
Yeah, healthcare. Huge potential there.
In education, imagine these interactive learning environments where the AI can walk students through complex concepts and provide personalized explanations, adjust the teaching based on how the student is doing.
It's like having a personal tutor for every student tailored to their individual needs.
Exactly. And in healthcare, wow, AI that can analyze medical images, detect things that maybe a human doctor might miss.
Early diagnosis, personalized treatment plans, even assisting surgeons during complex procedures, providing real-time guidance based on what the AI is seeing.
It's about augmenting human capabilities, combining the best of both worlds. I mean, the possibilities really are endless.
They really are.
But, with any powerful technology, there are ethical considerations, right? We need to be careful about how this is developed and deployed.
Absolutely. As AI becomes more integrated into our lives, we have to have those tough conversations about privacy, bias, and, the potential impact on jobs.
It's about finding that balance, harnessing the power of AI for good while being mindful of the risks.
Right. Responsible AI development.
So are you ready for some novel notions?
I'm always ready for that. Let's get speculative.
All right, here's one. We've talked a lot about how good VideoLLaMA 3 is at understanding the flow of events and videos. What if we push that even further? Trained AI to not just understand what happens, but why it happens.
Reasoning about causality. Wow, that's a big one. We're talking about AI that can infer cause and effect relationships, right? Not just describing what it sees, but actually understanding the underlying reasons.
Yeah, imagine an AI that could analyze a video of, say, a car accident
Yeah.
and not just tell you what happened,
Yeah.
but also pinpoint what caused the accident in the first place.
Or think bigger picture, an AI that can analyze historical data to understand the factors that led to something like, I don't know, climate change.
Exactly. Going beyond observation to understanding the why.
That would be a huge leap forward. We'd need new ways of representing data, new training methods, maybe even a whole new way of thinking about AI.
It's definitely a challenge, but it's an incredibly exciting challenge.
For sure.
Well, on that note of pushing those boundaries and exploring the future of AI, we're going to wrap up this episode of Talk Tensors. We've covered a lot of ground, from the technical details of VideoLLaMA 3 to the potential applications, and even some far-out ideas for future research.
It's been quite a journey.
It has, and as always, we encourage you to check out the full paper. You can find a link to it in the show notes.
And don't forget to subscribe to Talk Tensors for more deep dives into the fascinating world of machine learning.
Thanks for listening, everyone. Until next time.